That's perfect.
You and I both thought the same thing.
I love Chris Christie. I do. I can't help it.
So you can see the costliest big storms have been in the last decade or so. Here's the linkage between the climate crisis and the increased frequency of extreme weather events and the increased severity of extreme weather events. You saw one of the linkages from Dr. James Hansen saying that warmer oceans drive the power of windstorms. But here is, I'm sorry. First of all, 2012 we had $110 billion in climate-related disaster events. But 1 year earlier, we had Hurricane Irene, which was $15 billion, and so this has been building. And the only plausible explanation for these increased catastrophes is climate change, according to one of the two largest reinsurance companies in the world. And again, Jim Hansen is talking about these events, and I'll show you some of them. They're related to global warming. This is one of the leading atmospheric scientists. The environment, you will sometimes hear people say, you can't attribute any single big storm to climate. What the leading scientists are now saying is, actually all storms are different now, and I'm going to show you why and how.
One of the changes we've seen is that the average humidity of our planet has increased by 4%. Warmer air holds more water vapor, and so on average, our atmosphere is 4% more humid than it used to be 30 or 40 years ago. So when storms come through, there's more water for them to pick up and dump.
Catherine Hayhoe, by the way, was the scientific advisor to Newt Gingrich before, well, that changed, but she's a conservative Republican evangelical. As CO2 increases, so does the temperature. This is 2,000 years of the correlation between CO2 and temperature. As the temperatures increase, the oceans evaporate more water vapor into the sky. This is from the Oak Ridge National Laboratory. It's a computer simulation. What you're seeing is not rain. What you're seeing is water vapor. There are rivers of water vapor in the sky. And as Dr. Hayhoe just said, we're seeing an increase in that water vapor. The change in annual global temperature, the change in heavy precipitation days on average. You've all learned about the water cycle or the hydrological cycle. You know, after it evaporates into the atmosphere, this water vapor falls back as precipitation, and then the water returns to the sea. Basic elementary stuff. But what's new is, as again Dr. Hayhoe said, warmer air holds a lot more water vapor. If you take a hot shower in the morning, the mirror over the sink may steam up. If you take a cold shower, it will not. Warmer air holds more water vapor. And in fact, with each additional degree Celsius, the capacity to hold water vapor goes up 7%. So if we have an increase, they're predicting now, we could, if we don't act, you know, and we're going to act, but because you guys are going to be on the case, I hope and trust. But if we did not act, they're predicting like a 6-degree increase Celsius in this century. So what's that, a 42% increase in the holding capacity for water vapor? Already, there is a 4% increase in water vapor over the ocean than there was just 30 years ago. Now, here's something to remember about how that is linked to big downpours. This is a huge thunderstorm over Montana a few years ago. It just illustrates a point. The rainfall that hits the ground here does not always originate from the part of the sky directly above where it falls. These storms can reach out 2,000 kilometers and funnel those rivers of water vapor to the point where the drain is opened up. To put it simply, you know, if you have a bathtub full of water and you open the drain, the water going down the drain doesn't just come from the part of the tub directly above the drain. Obviously, it comes from the whole tub. But these giant basins of water vapor in the sky that cover large areas, when you have a 4% increase in that huge area, then the amount that goes down the drain is increased a lot.
One of the changes we've seen.
Oh, sorry. So the rainstorms and the snowstorms are getting bigger and they're getting more intense, causing bigger and more frequent flood events. Now, as the temperature continues to increase, this dynamic also accelerates. And what I'm going to show you next is just a shade more complicated, but not really. This is what happens. You get bigger and harder downpours and simultaneously longer and deeper droughts. And I'll show you why. But first of all, again, the water cycle, the evaporation into the air increases, the warmer air holds more water vapor, the downpours get heavier, causing worse flooding. Then, remember, the snowpacks melt earlier in the year, so you get spring flooding, not the water in the summer when you most need it. And there are longer intervals between downpours in the drought-prone areas, and water evaporates more quickly from the soil, making droughts deeper and longer. Now, it seems like an irony that you can have more floods and more droughts, but here's how the droughts happen, just to single out these two. The intervals between